Hi, this is number 54, spiral matrix. So given an MN matrix, return all elements of the matrix in spiral order. Okay, so it must start from index 0, matrix 0, 0, and when it will first let's see if there is any limitations. Okay, so is it like how big is the matrix? How many rows will it have? Okay, so at this there is one row, and we will have to return the flattened matrix in the spiral order. So so the value in the matrix does not matter. Like, we don't have to do any operations to the value in the matrix. And so we will start for the solution. And so the first thing that I came up is, I'm trying to find some rules that so I will always start from, let's write it down. So start from 0, 0, and it will go right first, and then go right, and then it will be down, and then it will be left, and it will be up, and it will right. But maybe for direction we will I'm just thinking if we don't keep track of the direction, but we keep track of whether it is visited. But at the for like the first row, there is they always have the opportunity to go down, so I don't think that's a better solution. I think we will stay with keeping track of the direction. So the direction will be the main thing. So it is. I think it still needs to keep track of whether it is visited, but I think we can do it in place, like the matrix value is only between -100 and +100, so we can do it like if we have already visited the value, then we will replace it with an infinity. Then if we if we met another, yeah, we will go through. If we met the boundary, we will change to another direction, and or if we did not meet the boundary but we met a visited node, let's say node. If we met a visited node, and we will also change the direction. Yeah, how about the solution? I think it sounds quite well. Yeah, and if so, the termination will be if there is visited, if the next node is visited, and if we change direction, it is also visited, then we can return. Yeah. So let's start from 0, 0 and go for right. So we have to keep track. We have to keep track of which direction we are now in, and I think we will have a map, an array, like okay, so the algorithm will be started from 0, 0 and go right first, and if we met boundary, or if we make a visited node, change to the next direction. I think maybe like for each node. Okay, so let's stay with the same solution. And then if no way to go, we will return. So we will have a direction array to loop through. We have like right down. Yeah, we have to follow the direction like this, left and then up. So for while answer is an empty array. So okay, we will have answer can be an array that is let's first have a constant to store the length of the matrix. So for I in range MN, answer I will be matrix or maybe we will have it like I am not sure, but because it seems like going deep, I am thinking of using depth first search. And this will be the matrix index and also the direction. So if we map the boundaries like I is smaller than 0 or j is smaller than 0 or I is larger or bigger than m or j is larger or bigger than n, we will so when we first we will change the direction. So now how can we change Oh, I think we have to like first checking the next one and see if we have to change. So it will be like if you'll have to see if direction is right. Then we will have it to if direction is right, we will first push ourselves into the answer. And we will start checking the next node. So if the direction is right, we will check if j plus 1 is smaller than m. Then we will have DFS I j plus 1 with dear. Okay, we will have it like so direction is right, then we will have I want to start it like DFS 0, 0, right? Then when we enter, we will append the current node inside answer, and so if it is right, then we will move on to the next node and we'll keep the direction right. And so so we will again run this function, and now it's like 0, 1, and 0, 1 is 2, so we will append 2 inside the answer. If the direction is right, then we will move on to the next, which is 0, 2, and 0, 2, direction is right as well. So we will then enter this function again and append 3 inside answer, so the direction is right. We have to check is okay, so the next one will be 0, 3, which is out of boundary. And if it is out of boundary, we will have to change the there. We will go to down. The direction will be down. Oh, but this is still 3, so yeah, kind of like if if there is equal to right, and if j plus 1 is smaller than m. Else we will have, else it will have like okay, so n is 3. So when we move on to 2 is 1 for j, and if it's already, yeah, so when we have 2 and 2 for the j, then we will go to the down direction. And we will have I plus 1 and move j. Yeah, and then we will have if gear equals down, if I plus 1 is smaller than m, we will keep moving down. Else we will have turn left. So it will be like DFS. Left. And if there is left, if it's boundary, so if j minus 1 is larger or equal than 0, DFS will keep moving left. Else we will have to move up. So it will, left, it will be like this. Then we will move up if it meets the boundary. And if its direction is up, then we will keep moving up until it meets the boundary, which is I minus 1 is smaller than 0. So let's first keep moving. And yeah, so where to stop, like when, and we have to after we append, we will change the matrix into like an if thing. So it is like recorded as visited, and if matrix is already visited, return. Oh, we did not return answer. Okay, so it seems like infinite loop. Let's check anything went wrong. So if we started right, it's not if, so we will not go into this condition. It will append, matrix will be if, and so if it's right, it will keep moving right, and okay, I want to track the solution since I am not really sure what it is, what this problem wants to ask, like which topic. Oh, this seems the same as my thoughts. Oh, I have done the same thing as well. Yeah, I think seems like I have came up I am in the right direction, but for the implementation it's kind of messy, like okay, I'm not sure for the third point. Like, what does it mean by when you move every time the row, the column number oh, okay, I got this. It is like yeah, so you will be doing a for loop. Yeah, like this is the value that you have to add up. Like if you are currently moving to the right, so you will add up this value to, like, your row should add 0 to your row, your current row, and your column should add 1 to your current row, so that you can move it to the right. Okay, the key thing, okay, this part is interesting. Yeah, the key point to like recursively following the direction, like right, down, left, up, and then going back to right. The solution here is to use a module. How to pronounce it? Like. Module. like how to read it. Okay, modulo.
Modulo.
Or mod. Does it? Oh, 10 mod 3. Okay, so it will be easier. Module. Why there's no Google like translation?
Modulo.
Modulo by, okay. Okay, that's back to, where is it? Okay, this one. Modulo. So, yeah, the key point for looping the directions will be, yeah, it's quite smart, like oh yeah, you will plus 1 for every time you move, every time you change your direction, but you mold it by 4, and then mode. You say mode or modded? Let's say modded by 4, then yeah, you will be back to 1, so it's quite smart. Let's see how it loops through every, oh, so it kind of, oh, it used like m multiplied by n and loop. Okay, so the first thing they have done is same as me, like you first append yourself inside the answer, and then you will record, like you will record the metrics to none, or anything that is not, that will not be the value of the in the matrix. And then you will try to find the next position. Okay, so if and okay, so if you will first try to find the next position. If the next position, like the column of the next position is out of boundary, or the row of the next position is out of boundary, or it is already visited, then you will change the direction, and Okay. Oh, they don't have to deal with how to stop, since they use the they use n multiplied by n as how many the number of steps they will perform. So at the end it will stop. You don't, if you walk through correctly, it will stop in the correct point. So yeah, it's okay. Oh, but why there is I and j here? Because I think it already. Oh, because if you have changed the direction, you have to do the calculation again. So yeah, I will be the next direction of it's kind of cool. Okay, so after reading the solution, let's go through again for this problem. Yeah, we can stay with the direction with the right down, left up, and do the calculation ourselves. Yeah, I did not think of. Yeah, I don't know where to start. I don't know. I cannot think of starting. Yeah, I don't know how to loop through. How to start walking through the matrix. Yeah, I did not came up with thoughts. So we will first append ourselves to the answer. It will be matrix. Yeah, I don't know. Oh, we will have which direction we are in. So we will have di started from 0. So and we will have the starting point. So this will be ij. Yeah, and like I don't know how to start. Okay, so let's first append ourselves into the answer, and we will change ourselves to a value that will not never appear in the matrix. So maybe like if, and then we will try to find the next step. So next step will be I plus okay, I think if we have like 0, 1, it will be easier because yeah, and for down it will be 1, 0, and for left it will be -1 and 0. No, it is 0 and -1. And then it will be, for the up, it will be -1 and 0. So it is like direction, di 0. And next j will be j plus direction di with the column, and so if let's check if an I is larger than m, or an I is smaller than 0. Larger or equal, or nj is larger than n, or nj is smaller than 0. If it's out of boundary, or if the next value is visited before, then we will have to change direction. So how to change direction? We will move di di will be equal to di plus 1 molded by 4. So, the real next I will be direction DI0 and J will be yeah. Okay, so there's another solution that if you don't I think that's all for this this problem.